All right, now we're going to take what we just did with velocity, position, acceleration, and we're going to apply it to other rates of change that aren't velocity. But the basic concept is still the same. And so what that should tell you is that these problems are on here not once, but twice. And 3 times if you have a general, here's a graph of F prime, do something with it, and it doesn't have any words around it. That's the same question as on this exam 3 times. Okay, so this is really, really important. Okay, we're going to use 2004, Form A, number 1. The first thing you need to do is just read it. Okay? The samples I've given you, 1, 2, and 3 are with the calculator. When we get, I'm going to give you another sample later on. There's a whole one that's, I've got one I can give y'all this, only the first 2 are calculator. Okay, I'm going to say that a little bit later. Okay, when you can be guaranteed one of those 2 problems is going to have a wonky function. Okay, something yucky. Somewhere on here they're going to test your ability to type this into your calculator correctly. Okay. So it's a trig function, so you make sure your calculator's in radians. And I don't even have the answers to this one on here because I'm not, okay, stop. I don't want you to do it right now. I'm just reminding you. Because what I want to get at on these problems is the plan. All right? I'm going to leave the execution up to you. I'm going to get the plan down for every problem. And then I have a whole stack of scoring guides. And once you execute them, you can come in and look at my scoring guides, and they'll tell you whether you got the right answer or not. Okay? All right, let's get the plan down. So when you read this problem, do you see that sort of thing that I was talking about? They've given you a function that is a rate of change. Yes? I'm telling you, all of my former students, since I started teaching this particular method, which was about 4 years ago, with, oh my gosh, this is huge. Write this on your paper. What are the units of F? Cars per minute. Just write it down. Are you going to get any credit for this? No. Is this going to help you make sure you get the right answers? Yes. Okay? And don't worry about what they asked you to do. Assume they're going to ask you to take the derivative somewhere. When they ask you to take the derivative, what will those units be? Cars per minute. And assume they're going to ask you to take an antiderivative somewhere. They may not ask you to do both things, but just assume they are. What are the units of that going to be? Cars. So here's the backwards thing. If they ask you for how many cars, then what are you going to do? Take the antiderivative. Okay? Does that make sense? This tells you, that way you don't get mixed up about which way you need to go with it. Okay, so with that in mind, read question A. And then you don't need to say, oh my gosh, do I take the derivative or the antiderivative? You can say, I know what I'm doing in a very deep voice, okay? Because alphas are the best. During the first 30 minutes is not 1 to 30, it is 0 to 30. You don't need to write that function down. They know what it is. It's written right there on the paper. There's your plan. And do you know how to execute it? Do you know how? Yes. Do you need to practice doing that? Yes, but we're not going to do that right now. Okay. Question B. Oh, is something increasing or decreasing? Is something increasing or decreasing? How do you determine that? If F prime is positive or negative. So let's write our plan. f prime of 7. Positive would be, f is increasing, f prime of 7. Negative would be, f is decreasing, even though f itself is a rate of change. Okay, so what do you have to find? Do you need to take the derivative, or do you need to find it? You need to find it. Okay, you're going to do n derive on your calculator. Okay, you're welcome to take that derivative. Jean will. She'll take it. Even if she doesn't know how. Hi, Jean. Okay. So you're going to find it, you're going to determine if it's positive or negative, and then you're going to answer the question. Don't just put it's positive or negative, answer the question. Okay? You can't answer the question if you haven't told them what you're looking for. So if you leave this part, if this part is not written on your paper, and you write down f prime of 7 is -2, therefore decreasing, that's not going to get you full credit. It's only going to get you part credit. You have to have connected what you're looking for. Does that make sense? Okay, read question C. Oh my goodness, every time I turn around, they're asking me to find an average. Yes? The average value of what? Traffic flow. Do I have a function called traffic flow? Yes. Okay, so I'm going to do 1 over b minus a in the interval from a to b of the traffic flow. Okay, my plan. Do I know how to execute it? Yes. You're going to do function integrator for this, and then you're going to forget to divide it by 5 and get the wrong answer. But hopefully you will remember to divide it by 5 and get the right answer. Okay? And look up at the top, it says indicates units of measure. So let's just think through the units of this. You're going to get a number, because I'm not worried about what the number is right now. I am, but what are the units going to be if you take the antiderivative of cars per minute and then you divide it by minute? You're going to get back to cars per minute. Y'all see? Thinking through those units that I gave you. You see how that stuff at the beginning is helping? Get this stronger than one right. Right. Now read question D, because I'm telling you, when this question came through in 2004, the number of people that got C and D backwards was unbelievable. And yet, if you think about it, it's really quite clear. It says the average rate of change of traffic flow. That's a lot of words. And I spelled something wrong. I need to find the average value of the rate of change. The average value of the rate of change. So, 1 over b minus a, the integral from a to b. You need to put something in here that's the rate of change of the traffic flow. What you write down? F prime. Okay. But can you see how that would be easy to confuse? Yes? Okay, I said I only wanted to do a plan, but on this one we're going to do the next step. Okay? Because this throws people off sometimes. They're like, oh, I don't have F prime. How am I supposed to do that? That's okay, because you're going to take the antiderivative of the derivative, which is going to take you to F. You see it? This one, here you go. This one, you're going to actually have to take an antiderivative. Plug in f of t, take the antiderivative, the function integrator. Okay? But this one, you don't have to take an antiderivative. You're going to have 1 over 5. You're going to take the antiderivative of f prime, which is going to take you to f. Plug in 15, plug in 10, and get your answer. Does everybody see? This is so common. And even if they're not quite, this is the most straightforward one. They started putting these questions all like not lined up like this. But that question is going to be there somewhere. The difference between the average value of something and the average rate of change of something. Okay? When you put this in, it says indicate units of measure. Okay. What? You think it's 30? Yeah, you're just F. What are the units of F? forgot what the word, go back to the beginning. Cars per minute. And then this is 1 over minutes. So this is going to be cars per minute. This is like acceleration. This is just like me giving you velocity and asking you to find position and acceleration, only it's cars per minute instead of meters per second. So I see? Okay? Now they don't get any more straightforward than this. That's bad news. Okay? But let's find another one and work through it. Okay. Let's go to 2004B, number 2. Where did they come up with these questions? On a tropical island. Okay. What's your clue that this is what I call these flow rate problems? They call them functions given as rates of change. Your clue here is that the function they give you is a rate of change, even though it doesn't have a prime on it. So what's the function they give you here? What's it called? R. What are its units? Okay, mosquitoes per day. And as soon as you see that, you're going to say, all right, they're going to do something and tell me to take a derivative, and they're going to do something that's going to require me to take an antiderivative. Let me get the units on those. If you don't get anything right on this problem, you'll get your unit points. Although they've gone to, like I think I've told you this before, they've gone to 1 unit point. You have to get all the units right to get the 1 point for units on the phone. That's actually probably better. So R prime is mosquitoes per day. And another little thing you might consider adding is this is the rate of change of R. If you're still a little bit feeling like, oh, I'm not quite sure I've got the handle on it that Ms. Farmer seems to think I have, adding that one little note might help, okay? All right, and then the definite integral, or the antiderivative of R will be mosquitoes, or if you want to put number of mosquitoes, okay? All right, here we go, we're going to plan. I hate it when they ask me to show that. That's because they tell me to do something, you know. The number of mosquitoes is increasing. How would you know if the number of mosquitoes were increasing, or the other time they said, is it increasing or is it decreasing? This time they just say to tell you what it is, and they say, how do you know that? So what are you looking for to know that? Yeah, you're looking for this. We're going to find R6. Tell me what it is, and show me that it is greater than 0. What throws you off here is that all year long, we've done rates of change that had a prime on them, okay? And now there's not a prime on there, but it's still a rate of change, okay? All right, second question. No. All right, some of y'all have got the hook, but let me just go back up here. I'm going to go back up here to this and put this back to sort of connect these back to velocity, position, and acceleration. Okay, if I went back up to this one would be position. It's okay if I call it X. You don't want it X, position. This one would be velocity, and this one would be acceleration. Yes? Okay, so increasing at an increasing rate. Increasing is like velocity positive, and increasing rate means that they're going to have the same sign, acceleration positive. So this means they're going to have the same sign, and specifically because it says increasing, they both have to be positive. Now I've said velocity and acceleration there just to poke you with that speeding up thing. Obviously that's not really part of the solution. okay? So which one of them sort of represents velocity up here? R? Yes, so what we really need is when is R positive and when is R prime positive. That would be increasing at an increasing rate. Okay?
So the increasing rate is
The rate, yes, it is. So the question actually says increasing at an increasing rate or increasing at a decreasing rate. So let's see if we can figure that out. Is this at 6? Is this the, so it says increasing at a decreasing rate. All right? Well, increasing still means R is positive. But if the rate of increase is decreasing, that's like slowing down. Yes? It may be positive, but it's slowing down. So what would this be? R prime of 6 would have to be negative. That's what you're trying to determine. That's definitely not any words you've seen on anything I've given you yet. But do you see how it's like speeding up and slowing down? Yes? Okay, so what is it you really need to find? What do you need to find?
R prime.
And you can find R of 6, and you need to find R prime of 6. And do you have at your table means to do that? Yes? Okay. So if you just do this, look, if you just do this, and then you tell me the answer, and you never explain what you were looking for, this stuff up here, then you're not going to get full credit for your answer. Okay? So that's why I say justify first, and then go do it. It's like plan, and then execute. Okay?
Justification.
What?
You can write that as a justification.
Yes. Now, I'm going to say it's also correct if you write this down and you get the two numbers and you say, I don't remember what they are. Let's see, I think it turns out that this one's positive and this one's negative. And if you put that in there, then they can give you credit for it as long as there's enough there. But it just doesn't make any, it's okay, I won't mark it wrong or anything, but it doesn't make any sense to me for you to not do it the way I'm saying. Justify first. That's what your brain's thinking anyway. Put it on paper first and then do it. Okay? In fact, when I sit down and I get a new one of these and I have to work it out to decide if I'm going to use it, I don't even work them. I just plan them. I think them through. What is it they're asking me to do here? Okay? All right, question C. I haven't got to it, but I'm pretty sure they're going to ask me to do an anti-corrective. What's it asking me to find? Number of mosquitoes. How do you find the number of mosquitoes? Definite interval. What goes in front of it? Some value that they've given. Now you can put 1,000 and that's perfectly all right, but what do they say times 0? I'm going to say M of T equals number of mosquitoes. I kind of like doing this. You don't have to do this. I'm going to put M of 0 plus the integral from 0 to 31. But certainly you don't have to do that. This is just my little pet peeve. You can also just write 1,000 right there. And if you're going to do that, you have to define the function. That's somehow that makes me think through it a little bit better. But the 1,000 is perfectly all right. You just have to remember that the number that you put here has to be from the same time as the time you put right there. Okay, Haley?
So would you try to define, or you try to define?
Yeah, I wrote it right there. If I'm going to use it, and it's not defined for me, I have to do it. Well, they do sometimes define them for you. At the top, they say if M is the number of mosquitoes. But you can always do it for yourself. This I just like because it drives home this point, that 0 and 0 thing. Okay? Does everybody see how you do that? Yes? Okay. We're going to answer to the nearest whole number. Number 10. Typing number D. What? Letter D. I want to maximize the number of mosquitoes. What do I find? Where the rate of change of mosquitoes changes from positive to negative. What's the rate of change of mosquitoes? R. So I'm going to look for where R and T changes from positive to negative. Okay. This is not a maximum when you do this. It is a relative maximum. Yes? Okay, I'm just going to put at C equals, I'm going to put a box there. I'm going to put K, some number. We're going to find the number. Okay, look at the graph, find the number. Okay, now, I, for the life of me, don't understand this. The one I showed you a few minutes ago, I said they get full credit if you just found the relative maximum, but on this one, you have to do the endpoints. Okay, so I don't know, always do the endpoints if you can, at least write them down even if you can't figure them out. So you need to know, can I use my M thing? M of 0. I think I just got going, I need to call it something. What is the number of mosquitoes at the beginning? 1,000, okay? What is the number of mosquitoes at that value that you found up here? Write it down. And then you need to find the number of mosquitoes at the end. I think we already did that, didn't we? How many mosquitoes will be on the island at time 31? Isn't that the end of the problem? And that answer was in part C. You get that answer from C. And then you're going to compare it. So here's my little tidbit. Okay, it is possible that they will disregard endpoints, but it is more likely that they won't. Okay, so you would get some partial credit if you just found the relative max, but you wouldn't get full credit. Okay, is that right, see? Not too bad? Okay, great, we're going to finish early. Okay, I want you to look at 2005A. I want to see if you can find the problem. Yep, it's number 2, okay? And something just sort of jump out at you about number 2. What kind of jumps out at you about number 2? Okay, sine and pi, always our favorite. What else? There are 2 of them, okay? There are 2 functions, but both are rate of change. One is the rate that the tide removes things, and the other one is the rate that the tide brings things in. Yes? So it's like you got a big bowl and something's dumping stuff in the top at one rate and something's taking it out at the bottom, but it's not at the same rate. So you need to figure out what's going to happen to this thing. Okay. You want a real life situation about this. The sand is one of them, but something that happens every day and you should be grateful for it is the sewage treatment facilities. Because stuff comes in and gets dumped in there and they do a bunch of stuff to it and a different kind of stuff comes out. Okay, and they've got to keep all of that straight in the sewage treatment, or just water treatment place, even if it's not sewage. Okay, so you recognize the kind of problem. So you're going to go up and you're going to write your units. Okay, again, no points for this, but this is going to help keep you straight, keep you centered. This throws us off a little bit because our unit has an exponent on it, but cubic yards is just a unit. It would be nice if this was a metric. Karen?
Would it be helpful and acceptable to make it negative units?
We're going to need to check that out in a few minutes because this is stuff going out. Okay? This is out. And you might note that these are going to have the same units, but it's in. Does that make sense? And so we're gonna have to pay attention to the sign, SIGN of this thing. Okay? And they gave me this thing at the beginning. You see that initial value up there? If you get to a problem and it's told you that and you haven't used it anywhere, you can bet it's supposed to go in the front of a definite interval somewhere. Okay? All right, ready? Question A. How much sand? What do we need to find? Definite interval. Okay? How is the sand measured? In cubic yards. Okay? So A is definite interval. Definite interval from 0 to 6. And this was asking me about how much sand will be removed. Okay, so that's just the R. Because the other one is the amount of sand that's being dumped back on. So you have to read the problem. There's no way I can predict what it's going to ask you. I just have to read it.
Added and not removed.
You know, it asks to see how much sand will be removed. So, yeah, there's going to be a question later on about the net, okay? But this is just about removal, so you pick the function that's talking about removal, okay? I could ask you the same question, how much sand was dumped on during the first 6 hours, and that would be a S of T. Does everybody see? Okay, read the second question. You get to make your own formula, yes? And they told you what to call it, that's the marks. Okay, so there's 3 parts to this formula. There's the sand going off. There's the sand coming on. What's the third part? There's the initial amount of sand that existed before it started, okay? So I like to put that one first. I started with 2,500, right? And you can put it either or you want. I'm going to add sand. And I'm going to take away sand. Now, what is this measuring? How much sand? If I want to measure how much sand, then it's definite intervals. Yes? How much sand? Cubic yards of sand. Okay? Hang on to that one. Let me make sure everybody's got this. Yes? Okay. Now, then you need to double check that this value, when you plug numbers into it, is actually positive numbers. And then since I think they are, since they're positive numbers, you got some minus in there, or you're just going to add more sand onto the beach. It's pretty clear, but you can just double check that. And then the second thing is, why did I put X's there? Because this function has to end up in T, so I have to put something here from 0 to T. And just take a look at that and see if that looks familiar. When they graded this, when they scored this problem, I think they were pretty lenient on this change of variable thing. But you have to have from 0 to T here. Yes? Again, I think they were pretty lenient and people had DTs and DTs in here. I think they didn't take off, I think it was nothing, but they might have taken off just 1 point and not worried about the change. Okay? All right. Question number 3. That's all you have to do for that one, you know? You could also have put this together, since they're both from 0 to T, you could have done it like this. And that would have been okay. You can remove this time. Okay? Question number C. Find the rate at which the total amount of sand is changing at T equals 4. That's right. Y prime. The rate at which the total amount of tonnage changes. That's okay, y prime isn't hard. Okay, because what's the derivative of 2,500?
Yeah.
What's the derivative of the antiderivative? The function. And what's the derivative of the other antiderivative? Yeah, just look, you look at that and you go, wow, and it's this. That's all that it is. Okay, you see what I'm talking about with the units and grabbing a hold of what it means, what the units mean, and they help you get to the answer, okay? And then the last question, D. You tell me which do you want to do. You're going to find the relative min, and you're going to look at the endpoints, right? Relative min of what? What? Wait a minute. Wait. Listen to the words. Relative min of what? The amount of sand. That's y. And you do that by using y prime. Y'all see? Okay. So the relative min of y. So that means you need to set y prime of t equal to 0. Yes? Okay, what's y prime of 4? S of 4 minus r of 4. What's y prime of 9? S of 9 minus r of 9. What's y prime of t? S of t minus r of t. Do y'all see? I'm not telling you this is easy. I mean, it's not easy to see in the heat of the moment, certainly. But just recognize that this is S of t minus r of t equals 0. You have a calculator, okay? And you can figure it out from there. Does that make sense? Okay?
Why is it equal to 0?
Because 0 is a critical number?
So earlier we had to say that changes from negative to positive.
Okay, yes, and then we have to determine where it changes from positive to negative. I'm sorry, I'm piecewise this, sorry. First, and whichever one, I'm sorry, Emma, you were completely and totally right. Okay, I should have said this first. You were complete, she's absolutely right. Right here, I should have said y prime of t changes from, I'm minimizing, negative to positive. I'm sorry, I got so excited about this little thing here that I forgot to justify before I worked the problem. Okay? And technically, if you do this and then you say that, it's still right, but I really believe you should say this first. Okay? Are we good? All right. All right. So then you're going to use your calculator to solve this and determine where it changes from negative to positive. Okay? And then you're going to do the endpoints again. So what is the beginning of this? Y of 0. I think that we know y of 0. It is 2,500. Y of whatever number you get from that relative min. And then y at the end. What's the end of this? Y of 6. And you know, unlike the last time, they hadn't already asked us this question. But you tell me, how are you going to find y of 6? How do we find y of t? You just put it in here, okay? So y of 6, go back to b. Let's look at b. It's going to be 2,500 plus the integral from 0 to 6. And I'm going to put s of t, or s of x minus r of x, t, off the dt. X's, T's, whatever.
So why would we see it?
If you put X's, it would be fine. The little thing at the top is just because they're supposed to be two different variables. You change from one to the other. Okay? All right. Yeah. What I'm hoping that you saw, there's two things I wanted to get out of this. Well, first of all, was that whole introduction of that flow rate thing and the idea of the units helping you see it. But I also wanted you, to see, I forgot what I wanted you to see. What did I want you to see? Oh, that they start putting different, like you get, this is a kind of question, but then there's something random. popped in there, okay? They don't always ask average value, they ask it on this one. They're gonna ask you average value somewhere, okay? It might be on a velocity question, it might be on a flow rate question, it might be on a related rate question, it might be on anything, okay? So I want us just to take a minute and look through and mark the problems now that Ms. Farmer thinks you ought to be able to do, okay? It's August is spring break students. Look at 2005B and see if you can find it. Did you find it? Number 2, water in, water out, yes? Okay, look at 2006. 2006A. Yeah, number 2, and look what they gave you this time. In addition to the function, they decided to go ahead and give you the graph. I don't know if that's good or bad, it just is, okay? But they've given you the function. If you need an exact value, you use that function. If you need some sort of generality, you can look up the graph, okay? Yes?
In 2005, point B, would it be 3?
2005, hold on a second. Part B, number what?
Number 3.
Depth of velocity problem. Didn't you work that one already?
Oh, yes.
Yes. So, okay, so let me say this again. By you asking that question of saying, isn't this the same kind of problem? Do you see that they put 2 of the same kind of problem on these tests? One of them they call velocity, and one of them they call something else. It's the same problem, okay? And then sometimes they actually put that graph on there. It's the same problem. Okay, graph that. Look at 2006. Oh, we already did that one. 2006 B. 2006 B. Yep, it's 4 calories per minute. You see it? Ooh, calories per minute. There was a velocity one on here that's funky. It's got a table and Riemann sum. It was number 6. And there was a regular old one on there also. Okay, so 2007. Yes, and it's just awful. Check it out again. You can just see it in the graph, can't you? It's just awful. Okay, it just throws you off by looking at it. It's not really as bad as it looks, but it throws you off. And the last one, 2007B. Two is the velocity one. Turn page. 3 is in wind velocity, miles per hour. You see it? Wind velocity rather than velocity of the car. And question number 4 is the graph of F prime. 3 problems in a row, and I'm telling you they're the same question. Okay? So 3 out of 6 problems, the same question. Okay? And we finished early. Yay! Bye, y'all.